So on the first one, I'm just going to subtract 14. Maybe I'm going to subtract 14. There we go. So I've got x squared plus 5x minus 14 equals 0. So give me two numbers that multiply to be negative 14 and add to be 5, 7, and negative 2. So x plus 7 and x minus 2 equals 0. Two things multiplied together that equals 0, so one of them has to be 0. So x plus 7 equals 0 or x minus 2 equals 0. Therefore, x is going to equal negative 7 or positive 2. Job. Number 2, there's only an x squared, so I'm going to get everything but the x on the other side of the equal sign. So subtract 3, and I get 3x squared equals 72. Divide by 3, x squared is going to equal 24. Square root it. X is going to equal 24 is 4 times 6. So that's plus or minus 2 square root of 6. Okay. And then the last one, I'm going to get everything on the same side, the equal sign. So add 7x, subtract 24. So A equals 5, B equals 7, and C equals negative 24. Okay, so I've got x is going to equal negative 7 plus or minus the square root 7 squared minus 4 times 5 times negative 24, all divided by 2 times 7. Oh, 2 times 5, 2 times A, not B. So that's going to equal negative 7 plus or minus the square root of 49 plus 480. Let me look real quick. Yeah, 480, all divided by 10, which is negative 7 plus or minus the square root of 529, all divisible by 10, which is going to equal negative 7 plus or minus 23 divided by 10. So I've got negative 7 plus 23 divided by 10 and negative 7 minus 23 divided by 10. So that's going to give me 8/5 and negative 3. Questions? Awesome. Okay. There's still people writing, so I'm going to pause. Okay. All right, so we're moving on to part 2 of solving polynomial equations. So basically, the fundamental theorem of algebra says any polynomial of degree n has n roots, but we may need to use some complex numbers. That means quadratic has 2 solutions, right? So if I have something to the 3rd power, I should have 3 solutions. If I have something to the 5th power, I should have 5 solutions. That's all that the fundamental theorem of algebra says. So whatever my highest degree is how many roots or zeros or x-intercepts I should have. Okay? So that's what it says. So to find the zeros of functions, we need to solve the equation f of x equals 0, right? We set the equation equal to 0 and solve. In general, the degree n of the polynomial function tells us how many solutions, roots, the equation f of x equals 0 has. So for a linear equation, n equals 1, right? So I have a power of 1 here. My answer is I have 1 solution, right? For a quadratic, I have 2 solutions. Although sometimes I have 1 because the square root of 0 is 0, so there's only one answer. There's no plus or minus 0, right? So sometimes I have 1. And then I have two, I can have complex roots, which I have 2 of those because it's plus or minus, so I can have that. The zero product property still works. If I have A times B times C times D equals 0, one of those things still has to equal 0. So no matter how many things I have multiplied together, if it equals 0, one of those things has to equal 0. So this says if I have x plus 1 times x minus 3 times 2x plus 5 equals 0, one of those has to equal 0, and I solve for x, okay? Just like I would do if it was a quadratic. And then the other thing we want to kind of talk about is the root property. So if a to the nth equals b, right, how do I get rid of that nth? I take it to the nth root, right? That's how you undo a exponent. The important thing is if it's even, if my root is even, so if n is even, 2, 4, 6, 8, my answer will be plus or minus. So I'll have at least 2 answers. If my root is odd, it won't. I will only have 1 answer. Okay? So I can have a negative inside my root then, though, because a negative times a negative times a negative is a negative. So I can have a negative inside the square root if n is negative. 3, 5, 9, right? Any negative root, I can have a negative in there. As example, x to the 7th equals negative 128. I take the 7th root of that, and I can, negative 2 to the 7th power is negative 128. Okay, so that works. So we're going to use those, basically only those 2 properties. There is no nifty little quadratic formula to find the other one. Usually what you have to do, usually what you have to do is long division, and you have to, there's this formula you can find to find out actually what goes into it. It's a long and involved process, and we're not doing it this year, to find out what you start dividing by, and then you use long division to find out how many times it goes in there, and then it's just a long and involved process. So we're just not doing that this year because of our shortened time. If you guys haven't realized, taking those Wednesdays out really shortens the time that we have to teach stuff. So we're not teaching that part this year. But just be aware of the fact that if you go on to calculus next year, they might teach it to you. If you're going into calculus in college because you're going into some science field, math or science field, you'll have to learn this. Just be aware that there's more to this than what we're doing, okay? That's all I wanted to say on that part. Okay, so we're just going to solve these, and we want to find out what my n. So we're doing 2 things. We're going to solve it. We want to find out what x equals, and I want to find out what my n is. What is my power? If I was to multiply this all out, what would be my degree? And I don't have to multiply it out to find out what my degree is. I don't have to do that. Because I can say x times x gives me x squared, right? And then multiplying by another x gives me x cubed. So my degree would be 3. Okay? I can imagine multiplying it out, right? I have 3 x's, I multiply it together, gives me x cubed. So I don't actually have to multiply it all out to find out what my n is. So I should have 3 answers. So I have 3 things multiplied together that equal 0. That means that one of those things has to be 0. So either x minus 5 equals 0, x plus 2 equals 0, or 6x minus 8 equals 0. And I just solve for x. So this one's going to be the hardest one, so I'm going to start at this one. 6x equals 8, divide by 6. So x is going to equal positive 5, negative 2, or 4/3. And that's it. Is there any questions? Zoomers? Everyone seems to be okay? Okay. Daniel, you okay? Know how we got the 5 and the negative 2, right? I would subtract 5 and add 2. Or, I'm sorry, add 5 and subtract 2. Wow, that was pretty bad. Okay. So if we go to the number 2, what would my n be on number 2? If I was to multiply this out, what would I get? What would my degree be? Oh, how did I get 3? Yes. Sorry, I missed that question, Jess. So if I was to multiply this out, right, I would FOIL this out, right? And then I would get x squared, blah, 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 blah. And then I would have that times 6x minus 8, right? And then I'd multiply that out, and I would get 6x cubed. There's my degree right there. So I'm only interested to find this part. I'm only interested in what the x's would multiply out, because the x's give me my degree. The exponent on my x gives me what my degree is. Did that help? Okay, awesome. So on this one, what would it be? So here I'm going to do x times x squared gives me x cubed, right? So my n would be 3. Okay?
Wait, so you don't do the other one too? The other x?
No, it's just the highest one. Just the highest one. Because the other one would be x squared, so that's not the highest one. Okay? Good question. And then I want to solve this, right? So I have two things multiplied together that equal 0. So that means that either x equals 0 or x squared minus 6x plus 9 equals 0. So I already have one answer, x equals 0, right? I just need to know if I can factor x squared minus 6x plus 9. So can I factor it is the question. And if I can, what does it factor to? So, right, is there two numbers that multiply to be 9 and add to be negative 6? Negative 3 and negative 3. Good. So then this factors to x minus 3 times x minus 3. And then I can say x minus 3 equals 0 and x minus 3 equals 0. Okay? So then x equals 0 or 3. And I know now it looks like I only have two answers, right? Because it's x equals 3 and x equals 0. But I actually have this how many times? Twice. So I do have three answers. Just one of them is a duplicate. And we're going to start writing this. I might as well go ahead and do it now. This would be 3. Oh my gosh. And I just told the word, you know, when it's in your head and then you go to say it and it disappears? That's what just happened. Multiplicity. It's called multiplicity of 2. So you can think of it as a multiple, right? A multiple of 2. I had it as 2. Because we're going to start graphing this pretty soon, right? Now that we're solving and we're finding the x's, guess what comes next, just naturally, is we are going to graph these. And so it just means I have an x-intercept in that same spot that has more than 1 in that same spot. So I have a multiplicity of 2. Could I have more than a multiplicity of 2? Yeah, I could have it like 3 in the same spot or 4 in the same spot, right? Does that make sense? I could have more than 1 in that spot. And I just have 2. And so we just put a little m. This m means multiplicity more than 1 in the same location. Okay, so I just had 2 in that location. Is there any questions about that? Awesome, you guys. Good job. All right, what's next on this sheet? Oh, okay, so you guys are going to do, oh, wow. Wow, okay. Let's go ahead and just do these 4 problems. And then we'll do the last 2 because I want to. So on this one, I've got x times x times x, which is x cubed. So it's 3. So 5x plus 1 equals 0, x minus 4 equals 0, and 3x plus 2 equals 0. So x is going to equal, subtract 1, divide by 5, so negative 1/5. Add 4, which is 4, and subtract 2, divide by 3, negative 2/3. Questions? Are you okay with that, Daniel? Okay. So I just did it right by doing what we normally do, right? Subtract 1, then divide by 5. I just didn't write it out. Is everyone okay with that? Okay. So number B, I have an x squared, right? Because x times x will give me x squared. And then times x is 3 again. I have 3 here. So the 2, I can get rid of the 2 by doing this. So I would have x minus 2 times x plus 1 squared. So that 2 doesn't do anything. It's just a constant. So, and that would equal 0. So I'd have x minus 2 equaling 0. And then I'd have x plus 1 equals 0. And x plus 1 equals 0. Because I have 2 of those. I have 2 x plus 1s. So that means x is going to equal add 2 and then subtract 1 with a multiplicity of, I have 2 of those. So I just put negative 1 m2. That shows me that I know that I have 2 negative 1s. Okay? And then C, let's see, we've got an x and an x is x squared times x and x is x squared. So that would be x to the 4th. So I should have 4 answers on this one. Woo, okay. So we've got 2x equaling 0, x minus 2 equaling 0, and then x plus 1 equals 0, and x plus 1 equals 0. So divide by 2 will give me 0. Add 2. Subtract 1 twice. So there's my answers. I've got 4 answers, 0, 2, and negative 1 with a multiplicity of 2. Any questions? Okay. Number D. I have an x squared times an x is x cubed times an x is x to the 4th. So it's also a 4. So this one gives me 5x plus 1 equals 0. And x squared minus 9 equals 0. And x plus 9 equals 0. So this middle one I can factor to x plus 3 equals 0 and x minus 3 equals 0. So that would give me x is going to equal subtract 1, divide by 5, subtract 3, add 3, and subtract 9. Questions? Or this middle one, I also, instead of factoring, I could have just said x squared equals positive 9 and then took the square root of it, and x equals plus or minus 3. Either way, it doesn't matter how you want to think about this one. Either way is correct. Okay? And then we have 2 more. So I'd like you to, if you haven't worked on those ones yet, the last 2, please work on E and F. They're a little tricky. Let's see if you guys this. This one, my N is pretty easy. It's just 3, right? So then I have x cubed equals 1, because I add 1 to both sides. So I cube root it. And the cubed root of 1 is 1. Now, I'm supposed to have 3 answers, right? But I only have 1. That's because 2 of my answers are complex. And we don't know what they are. We could figure them out because if we could factor, we have factored cubes. We could factor that, and then we could use the quadratic formula and find out what the complex roots are, but we don't have to. Okay? So, yes?
So even though there's one answer, the other one's supposed to be?
They're just imaginary roots. So when we graph it, what happens, and I'll just show you, even though we're going to look at it a little bit later, what happens with this is it kind of goes up, and then it flattens out because it has imaginary roots right there, so it flattens out, and then it goes back up like this. So that's what the graph looks like. So there's two kind of imaginary roots right there, and then it crosses at, well, I probably should have moved it over a little bit, or up a little bit, but it crosses at 1. So x equals 1. So this should have been over just a little bit more, but instead of crossing at 0, it would have crossed at 1. But yeah, so that's what it kind of looks like, okay? So, but it flattens out a little bit, okay? And we'll talk about what the graphs look like if they flatten out, and we're going to talk about that. You guys, and when we graph these, you're actually not going to like with a quadratic, we make sure it's exactly where it's supposed to be. We're actually just going to sketch these. So we're going to have the main points on our graph, and then the rest is just going to kind of be a sketch. It's not going to be exact because there's no way we can get it exact without driving ourselves insane. And we're not going to do that. We're just going to make sure we know where the main stuff is, and then we're going to sketch it on there. Does that make sense? Okay. So here, this one has x cubed and an x to the squared. So that would be x to the 5th. Wow, that was good English. X to the 5th. So I've got x cubed plus 8 equals 0, and x squared plus 8 equals 0. So I subtract 8 everywhere. And I've got x cubed equals negative 8, and x squared equals negative 8. So for the first one, I'm going to cube root it. And for the second one, I'm going to square root it. So I've got x equals negative 2 for the first one. And then, of course, I have some more complex roots, okay? So I've got some more, at least 2 more, because it's an x cubed. And then this one is going to be x equals, I have a negative underneath my square root. I know this is a 4 times 2, right? That's what 8 is. So it's going to be plus or minus 2i root 2, because square root of 4 comes out as a 2. And then there's that. And these are also, by the way, this is also a complex root because it's got an I in there. So it's a complex imaginary, right? Complex means it's imaginary. So I've got 4 imaginary roots in this last equation. So when I graph this, it's going to be really kind of ugly. But using Desmos will really help us with our sketching. Okay? Is there any questions on that? Okay, so really for the next 20, 50 minutes, you guys have delta math to do. I do have one thing I want to ask.